everyone. So we are excited to present our mini project titled Assignment Scheduler System by using Heap application for our course data structures instructed by our professor Dr. Manoj Shakya. So our team members include Niharika Karki, Subhapuda Saini, Ruchi Shakya, and Arushi Gautam. So I am Ruchi Shakya and I'll begin by walking you through the project overview and the problem we aim to solve. So, in this project, what we built an intelligent assignment scheduler that uses the heap sort algorithm to prioritize tasks based on their due dates. First, it allows user to input multiple assignments along with subjects and deadlines. Then, it automatically sorts these tasks using the heap sort algorithm to help users focus on the most urgent ones. So the scheduler provides an optimized study plan, making it easier for students to manage their workload. So overall, this project shows how heap sort can be used in real world situations, especially for academic planning. So to build our scheduler, we first had to understand how heap sort works, right? So here's the key concept. Heap sort is a comparison based sorting algorithm that uses a binary heap sort structure. So a binary heap is a complete binary tree, meaning all the levels are fully filled from left to right and it follows a specific heap property. In in min heap, there are two types of it, that is min heap and max heap. In min heap, the parent is always smaller than or equal to the children, so the smallest element stays at the root. In max heap, the parent is larger than or equal to the children, keeping the largest element at the root. So the process of heapify is used to maintain the heap structure after any changes or modification, like inserting or removing elements. So these concepts form the base of how our algorithm works behind the scene. So the simple rule is that heap sort always sorts elements from right to left in the array. If we want the data in ascending order, we use max heap. The largest element goes to the end and the process repeats. If we want descending order, we use min heap. The smallest element is moved to the end each time. So this rule helps us choose the correct type of heap depending on how we want to sort the assignments. So here's how the heap sort works step by step. First, we build a heap from the given list of elements. This means we structure the data into min or max heap. Next, the second step is we extract the root element, which is either the maximum or minimum depending on the heap type. Then what we do is place extracted element in the sorted position. That means we extract it in an array, put it in the array and keep it at the end. Then fourth step is heapify the remaining elements. That is, we move the last element to the root and adjust the heap again to keep it valid. Then at last, we just repeat these steps until the entire list is sorted. So this process is what powers our assignment scheduler and makes sure tasks are sorted properly. So now to understand how these steps actually work practically, let's just apply it in a simple unsorted array. In this project, we need to organize the assignments into an ascending order so that the earliest deadline would pop up first. Here, let's just try to understand the concept by taking an unsorted array and sorting it into a ascending order by using a maxi. So I have converted this array into a binary tree view such that in the position 0, 1, 2, 3, 4, 5, and 6. Right, so our first job is to build a max heap. In max heap, we know that the parent node is always greater than or equal to the children. So here we can see obvious that the parent node is not greater than the child node. So what do is we convert it into max heap by swapping the elements. We know we first check this node to the 5, 10 is actually greater than 5, so we swap 10 and 5. Right, similarly here 9 is greater than 8, so we swap 9 and 8. Now if we look at the root node, that is 2, since 10 is greater than 2, we swap 10 and 2. and similarly 2 and 5. Finally, what we get a max heap, and 10, that is the maximum value, is the root node. Now, our second phase is to do the sorting part. Now, how do we sort is by extracting this max element and keep it at the end, and we swap the max node with the last element, that is 2, so that the 2 becomes the root node, and then we again heapify the remaining elements. Now, since 9 has become the root node, that is the max number, we extract this 9 and again swap this position with 1 and then again heapify the remaining elements. Now we repeat the extract and fixing the heap until and all are sorted. Finally, the sorting is complete and heap sort is complete. So array is now sorted in ascending order. So this is how we sort the array using heap sort step by step in ascending order.
Hello everyone, I am Niharika Karki and I will be further explaining the presentation. So for my part, I will be talking about how did we do the program to make this assignment tracker. So before that, we already know that assignment tracker helps to manage multitasks by organizing them based on due date, and for the organizing it by due date and importance, we have used HipSort. So the main motive of making this assignment tracker was that we often struggled with deadline, forget assignments, or don't know which tasks to prioritize first. So we came up with a solution that is assignment tracker, which helps to show which task should we focus on next in a clear and sorted way. So let's hop into the program. First, we have imported JSON file, then we have imported date, time, and OS. So JSON file stands for JavaScript Object Notation, which permanently stores assignments, so nothing is lost when the program closes. In For the date and time, it helps to module us with the date, and the OS checks if the file exists or not. In the very beginning, we have defined assignment file to store the file name where assignments will be saved. Then we have checked if the assignment exists or not. If the assignment exists, it further continues with the program, and if not, it returns an empty list. In the save assignments part, it takes the list of assignment dictionaries, convert each assignment's due date from a date-time object to a string year, month, date, and it writes the whole list back to JSON file, formatting with indentation for readability. So here comes the main part, which is heap sort. So for the due date and marks, to prioritize with marks or due dates, we have used the heap sort. So first we heapify. The array means the list of assignment, and means the size, and I means the current node, which is also the largest node as we have assumed it. And we also calculate left and right nodes. And here we have compared A and B. So this is a custom comparison function to decide which assignment is larger or has higher priority. First, it calculates the difference in due dates and between the assignment A and B. If the due date is in same date, then marks decides the priority. And here we have checked in this from this line we have checked if the left child exists or not, and if the left child exists, what what is its priority? Is it higher than the current node or not? If yes, then update the largest to left. And we do the same process for right as well. This finds which of the current node or the child node should be the root of subtree for max heap property. And if either child was larger, then we swap the current node with the largest child. then recursively heapify the affected subtree to maintain the heap property down the tree. Then here we build a max heap from the array here and start from the last parent node, that is this, and move upward to root 0 for each node called heapify to make sure the subtree rooted at that node satisfy the max heap property or not. And here in this loop we have sorted the heap, swap the root with the large element in the heap, and this whole process effectively places the highest priority assignment at the end, working backward to get the fully sorted list. Then from here we add an assignment. So to track the assignment we definitely have to add the assignment first, right? So we add assignment and we display which assignment should be done, like next task, what is the first task, next task, like task, like that. And if we have to delete any of the assignment, then we use this program. I will be explaining it one by one. And list all assignment means it lists all the assignments that we have input. So for the very beginning part, we ask the user to input strings for marks and due date. Then it converts. Here we can see it converts the marks into float and converts a due underscore string to date time in year, month, and date. If conversion fails, then it says invalid date format or invalid marks. And here we ask the user to input subject, title, due date, priority, marks, and completed is set as false for now because we have not completed the assignment. If we had already completed the assignment, we wouldn't have put it here. And after you have inputted all these things, it gives you a message that assignment added successfully. For the second part, it display next tasks. To display next tasks, so there are total 5 access 5, so there are total 5 of these, like add, display, delete, list, and exit. So it shows the assignment and which of the assignment are pending, and it prints the due date and priority and how many days left. So when it shows how many days left, we can know that which assignment due date is coming soon and which one should we be doing first, etc. And there are similar programs to delete the assignment and show the list of assignment. To delete the assignment, it first puts the value in index and we choose which assignment to delete, and it pops that index, means delete that index, and shows that assignment has been deleted successfully. And if, like, suppose you try to delete the fifth assignment but the fifth assignment doesn't exist, then it shows invalid index. And list of assignment means it shows the list of all the assignments that we have here, and it shows how many of those have been completed and how many of those have are pending. So it has similar kind of program. And for this CLI menu part, it displays a simple numbered menu repeatedly, takes user input to select option. Then if user adds prompt for assignment detail, it calls the as assignment. If list of assignment is if the user chooses list of assignment, then it calls list, and if chooses delete, then it calls delete, and so on. And in the very last part we can see that if it chose the fifth number, which means exiting the program, when we exit the program it gives you a message goodbye and the program exits, and it again starts with the choose an option to put the other assignments if needed. And we use if underscore name and this part to start the program by calling the menu function. So I've already run this program, so I'll quickly show you that. Here I have added few assignments, like in option 1 I have added calculus, mini project, and stars. And in the second part If I choose an option second, then it shows all of the assignments that I have added. So I have randomly added the dates. So these there's also a -1 day left. That means it has already exceeded a day. So since I have randomly added these dates, so it shows like this. And here we can see in the first, it asks the add assignment as we added that in the very beginning. And in the second, it shows list of assignment. We also just saw that. And in the third part, it asks to delete any assignment. So it asks here in the index to delete any assignment, which means if I delete 4, then the assignment has been deleted. The assignment 4 here has been deleted. The If I choose the option 4 next task, it shows which task should I be doing next. So mini project, there's only 6 days left, so it asks you to do this one first. And if I choose the option 5, that means exiting, then it gives you a message goodbye and the whole process starts again. So this is it for my part, and I talked about how our program worked. And we have also created a website using this program, which will be explained by Arushi. So now I would like to give this space to Arushi. So thank you, everyone.
Hello everyone, this is Arushi Gautam and I am going to present about a web page that we have designed using the function my friend previously told about. What this assignment tracker does is it helps students manage their assignments before deadline without them feeling overwhelmed. What makes our assignment tracker smart is the use of heap sort algorithm which sorts and manages assignment according to priority, which is marks and timeline. Now let me show you a quick demo on how assignment tracker works. Suppose I have a subject that is data structure, assignment title that is heap sort. The due date is 7/31/2025. Priority is high and the total marks is 15. As we can see here, now our assignment is added. So beforehand, I had added three more assignment, that is linear algebra, calculus and normal distribution. As we can see, our algorithm had color sorted all the assignments according to priority. So red color here indicates you need to focus maximum amount of time since you have very limited amount of time to submit the assignment. Yellow color indicates you have sufficient amount of time to finish the assignment, and green color indicates you have more than sufficient amount of time to complete the assignment. Our algorithm has also sorted all the assignment according to subject, that is data structure I have this assignment, mathematics I have this two assignment, etc. It has also sorted assignment according to priority, that is high priority assignment, medium priority assignment and vice versa. Status here indicates if the assignment is pending or completed. Here, since all of them are pending, let me add this assignment as completed. As we can see, as I click completed, this color changed into gray. So here count of completed also increased to 1. So as I view completed assignment, I have calculus that I have completed. I can also undo it. So now I can see here next task suggestion. Next task suggestion is for the students who feel overwhelmed and don't know what to focus on next. So for example, if I am a student working with this assignment tracker, then I must focus on data structure, heap sort algorithm and submit it by today, and then focus on linear algebra and so on. I have also added a calendar using CSS so that students have quick timeline overview on which date they have to submit which assignment. They can also add their plan according to what they feel like. Here is study timeline. Suppose I have completed this assignment and this assignment, then my study timeline shows that for 2025-84 I have completed one assignment, and for 2025-88 I have completed one assignment. So here is the plot of date and count. We have also added dark mode for people who want to work in dark mode, feel easy and comfortable to work in dark mode. Now that I've shown you the working demo of Assignment Tracker, I will briefly walk you through the main parts of the code. This project is built using HTML, CSS, and JavaScript. For dynamic element, I've used full calendar to show deadline visually, and to represent completed assignments on a timeline, I have used chart.js. This is the HTML code that we have written for Assignment Tracker. Inside style tag, we have introduced CSS, which describes the layout, the color, the font of every part of the web page. That could be either dashboard, the timeline, the calendar, etc. For example, here the dark mode is the class of simple CSS which toggles when the dark mode is clicked. Inside our HTML code, we can see the code being divided by using div tag. Div tag basically divides each of the web page sections. For example, it could be top bar, container, filters, dashboard, etc. For example, for container, we have subject, assignment title, due date, etc., which takes necessary input from the students. Now, this is the major part of our project, which is heap sort implementation. But since my friend has already explained about the heap sort implementation and we have used the same exact function here, I would rather just skip it and move forward to JavaScript part. As you can see, we have introduced many JavaScript functions. Among them, I am going to explain some of them due to time limitation. For example, here in add assignment, which is called every time a user submits request to add assignment to the web page. We also have clear input populate filters, filter assignment, which is responsible for filtering. We have update dashboard function. We have delete assignment function, which is again called every time an assignment is deleted from the web page. We have render next task, which is responsible for updating the next task list every time an assignment is added, removed, or completed. We have render calendar, and similarly we also have render timeline, which serves the similar function. This marks the end of my part. So to conclude, I would like to say this that this assignment tracker web page is particularly front end based, meaning the data stored here is not permanent. This web page is just a prototype to show how heap sort algorithm can be used in real life website. Thank you.
Hello everyone, my name is Subhapura Saini and now I'm going to talk about the real world application of assignment scheduler system using the heap sort algorithm. Our scheduler has a wide range of real world applications. In education, it helps students prioritize assignments by deadlines. In project management, it sorts tasks by urgency. It also resembles how CPUs of schedulers operate, and to-do list app can use a similar logic to push important tasks to the top. By using HipSort, we ensure that tasks are always organized in the right order based on their priority or due date. So now let's talk about the pros and cons of using HipSort in our scheduler. Pros include it's time efficient with the time complexity of big annotation and login. It uses no extra memory, which is great for performance. It naturally aligns with priority based sorting. However, the cons are it's not a stable sort, so tasks with equal priority must be reordered. It has poor cache performance due to scattered memory access. It's more complex to implement than simpler sorting algorithms. So, after implementing the scheduler, we observed that tasks were correctly arranged from most to least urgent. Each assignment had a priority, and Heap Sort handled the sorting flawlessly. This system works best when all tasks are available in advance, what we call static scheduling. In dynamic or real-time environments, pairing heap sort with priority queues or min heaps would work better. So, in conclusion, the assignment scheduler using HipChart organizes tasks by urgency, helps users focus on what matters most, and shows how classic algorithms can solve modern problems. Although HipChart performs well, it's best suited for static lists. In dynamic environments, hybrid or heap-based approaches might be better. So, here are the key takeaways also. HeapSort is ideal for static, priority-based scheduling. Its consistent performance makes it reliable for large datasets. It's less suitable for environments where tasks arrive unpredictably on and many world systems like CPU schedulers or student portals can benefit from this sorting logic. Overall, we have shown how a foundational algorithm like HeapSort can power practical scheduling system. To sum it up, this project proves how a simple algorithm like HeapSort can make a big difference when applied thoughtfully in real-world scheduling problems. Whether it's managing student assignments or organizing tasks in a tech system, efficiency and prioritization are key. And that's exactly what our scheduler delivers. Thank you for your time. I'm happy to take any question.